This video is a demonstration of the mechanism of pin joint and rigid joint. Here you can see that the vertical member is attached to the base, but it is not rigid. It can be rotated in all the directions. This kind of joint can be called as a ball and socket joint, but we won't be using it in this exercise. However, what is more important for us is a pin joint. If a vertical member is attached to the base in such a way that it can rotate only in one plane, the kind of joint that it makes or resembles is a pin joint. In reality, a pin joint is made simply by inserting a pin at the junction where the two members join or overlap. These are some examples of usage of pin joint. Now, if I use these small triangular elements or sort of buttresses, the joint cannot rotate now in any of the directions. And this is what resembles a rigid joint. In reality, such joints can be made in various ways such as welding, bolting, other kind of wooden joineries and various other ways. Here are some examples. Despite so many ways of making a rigid joint, in principle, a rigid joint doesn't allow any mutual movement of the parts which are joined together. This video is a demonstration of bending moment in a cantilever beam, a vertical member or tower, and a simply supported beam. Here, what you can see is a vertical member. You can see that the maximum bending happens near the base, and towards the top, the bending or the curve becomes more and more gradual, becoming almost a straight line in the end. This is what it will look like. This means that when a vertical member is subjected to loads or forces from the sides, the maximum bending occurs near the base, gradually reducing towards the top. In the diagram, the grey hatched area represents the bending moment and its intensity. You can see that it is maximum at the base and decreases as we go up. Notice that the forces applied, which you can see on the left, is constant throughout the length of the tower or the member. The Eiffel Tower is arguably one of the best examples of this phenomenon. You can see how it is so wide at the base and becomes thinner and thinner towards the top, almost becoming an illustration of its bending moment diagram. Now we will try to understand the bending moment diagrams of vertical members, cantilever beams and simply supported beams. We will also try to see the difference in bending moment in all these elements when they use pin joints as compared to rigid joints. Now we will try to see the bending moment in a vertical member with pin joints and the same member with rigid joints when they are subjected to load from above. Here you can see that the member has pin joints on both the ends. When the load from above exceeds beyond a certain point, the member buckles, forming a smooth curve from one end to the other. And so, its bending moment diagram looks like this. Then here, you can see that the vertical member has rigid joints on both the ends. When the load from above exceeds a certain point, the column buckles, but because of rigid joints at the two ends, the buckled member does not form a singular curve but varying curves. This is how its bending moment diagram looks like. After this, we will see the bending moment diagram of a cantilever beam. You can see that a cantilever beam does not work in a pin joint as one of its ends need to be attached firmly to a support. In case of a rigid joint, you can see that the bending is maximum towards the fixed end and the member becomes almost straight towards the free end. It means that the beam needs maximum support near the fixed end and lesser towards the free end. And thus, this is what its bending moment diagram looks like. Let us now see the behavior of a simply supported beam with pin joints. Here, you can see that the maximum bending is at the center when the beam is loaded from above. And so this is how its bending moment diagram looks like. The maximum bending at the center suggests the need of maximum strengthening at the center. Now, let us see the behavior of the same member with rigid joints. Here as well, you can see that the bending is maximum at the center, but a curve can also be seen towards the two ends. Something like this. The behavior and bending moment diagram of a beam changes if it has rigid joints at the supports. And thus, this is how its bending moment diagram looks like.